I've got the graph of cosine up here on the board. And as we can see, as with every trig function, it is not invertible because it fails the horizontal line test. Because if there's a y value that it takes on, like here at pi over 2 it's 0, there are infinitely many angles, all odd multiples of pi over 2, at which it's going to hit that value. So in order to be able to create an inverse function, I need to create a new function which is still going to have the formula y equals cosine of x, but I'm going to put some restrictions on x. I'm going to restrict the domain so that I only hit each y value once. And as I do that, I'm going to be thinking in terms of picking an interval of x values that corresponds to 2 of my quadrants. And there are rules for how I do that. One rule is I always choose quadrant 1, and in particular, the standard copy of quadrant 1, angles between 0 and pi over 2, acute angles, because those are the easiest ones to work with. That's where I can use right triangle trigonometry. So I'm going to have this interval from 0 to pi over 2. Now that's where cosine is taking on its positive values. I can see I cannot use the same interval that I used for sine when I restricted its domain, because then I went from negative pi over 2 to pi over 2, and that would have me repeating the positive values but never hitting the negative values. So I can't use that. Quadrant 4 is out because cosine repeats its positive values there. Quadrant 3 is out because it's not adjacent to quadrant 1. And if it's not adjacent to quadrant 1, I'm not going to get a connected piece of graph. So it looks like we want quadrant 2, and in particular, the version of quadrant 2 that's adjacent to this version of quadrant 1. So I'm just going to keep going to pi. So this is my graph of y equals cosine of x, where x is in the interval from 0 to pi. And notice I am including those endpoints. That way there's an angle in here where cosine takes on that value of 1, and I'm including pi. There's an angle in there where cosine is negative 1. This is 1 to 1, so it's invertible. So I can define y equals arc cosine of x, which can also be written as cosine inverse of x, but remember that is an inverse sign, it is not an exponent. Very different from the reciprocal function. What that means is that x is equal to cosine of y, so I'm switching the roles of x and y, but I'm switching them everywhere. So, and y is in the interval from 0 to pi. So that is the definition of arc cosine. So let's try practicing evaluating arc cosine at some numbers. I'm going to keep that up. Okay. So let's say I wanted to evaluate arc cosine of negative 1/2. Okay. So I like to give that a name. I'm going to call it theta. That just reminds me that it's an angle. Okay. I could call it y, because it's the output of my function. Calling it theta makes me think angle, so it helps keep me on track. So now I know that with inverse cosine, I'm looking for something that's either in quadrant 1 or 2. So which quadrants I'm working with are gonna depend on which inverse trig function it is. Okay. All right. Now, this means, of course, that cosine of theta is negative 1/2, and theta is in the interval from 0 to pi, so in quadrants 1 or 2. Okay. If cosine is a negative number, I know that can't be in quadrant 1. I now know I'm in quadrant 2. So my theta is going to be this obtuse angle, and I'm going to need to find my reference angle here. Now, what I know about cosine of alpha is that it has the same absolute value as cosine of theta. So this is going to be 1/2. So I'm looking for the acute angle whose cosine is 1/2. I'm a triangle person, so that makes me draw my 30, 60, 90 triangle. And I can see the angle that has a cosine of 1/2 is 60 degrees, which would be pi over 3. Now that's my reference angle, but I was looking for theta. I can see that theta is going to be just alpha subtracted from pi. Because if I rotated alpha more, I'd be at pi. So if I go all the way to pi and then subtract alpha, that gives me what I want. So it's pi minus alpha. So it's pi minus pi over 3. I can write that as 3 pi over 3. Oops, minus pi over 3. Which is going to give me 2 pi over 3. So my answer here is 2 pi over 3. Excellent. Okay, I'm going to put another one up, and I'm going to have you folks try and evaluate this one. So let's try arc cosine of negative root 3 over 2. Okay, so pause the video, see if you can evaluate that, then tune back in and we'll check your work. Welcome back. Okay, I'm going to give that a name that makes me think angle. So this is my trig ratio, the output's going to be my angle. And I know that what that means is that cosine of theta is negative root 3 over 2, and theta's in the interval from 0 to pi. So 0 to pi corresponds to quadrants 1 and 2. If cosine is negative, which it is here, I know I'm going to be in quadrant 2. So my picture looks like this, very similar to what we had last time. Alpha is going to be my reference angle. And what I know about alpha is that cosine of alpha would just be the absolute value of negative root 3 over 2. So that would be root 3 over 2. I'm looking for the acute angle whose cosine is root 3 over 2. Once again, I'm going to draw my 30, 60, 90. 1, 2, root 3. That's going to be my 30-degree angle, which would be pi over 6 in radians. Again, with inverse trig, unless you are explicitly told that you are working in degrees, we are working in radians. That's an important thing if you're ever using inverse trig on your calculator, because most calculators will do inverse trig in either radians or degrees. So just like when you're doing regular trig, you need to make sure that you're in radian mode if you're doing inverse trig, unless you were explicitly told that you're working in degrees. Okay, so make sure that you are in radians. On most calculators, the way you get an inverse trig function is there's a shift or a second key that you would hit, and you would hit that and then the sine key or the cosine key or the tangent key. But it's going to vary a little bit from calculator to calculator. So even though I'm not really emphasizing calculator use this semester, we do use them from time to time, and it is important that you learn how yours works. So take a look at your calculator, see if it does work hitting shift and then the trig function key. If you have any troubles with it, take a picture of your calculator, send it to me, and I'll try and help you figure it out. Okay. All right, so let's see. We said our reference angle was pi over 6. Okay. So I can see that my theta is just pi minus pi over 6. That would be 6 pi over 6 minus pi over 6. So that's 5 pi over 6. Excellent. That's arc cosine of negative root 3 over 2. Nice thing sometimes when you're working with inverse trig, because it is a little bit unusual, just double check that you gave me an angle. If I was evaluating an inverse trig function, I should be giving you an angle. If you're giving me something like 1/2 or root 3 over 2, that technically could be the measurement of an angle, but probably you've gotten confused and are giving me the trig ratio instead. So kind of nice, that looks like an angle to me. I'm feeling good about that.